Okay, all right, we're good to go. Okay guys, thank you very much for being here. My name is Alex, and I'm gonna try to give you like the most painless journey I can put you guys through around machine learning and what that could potentially mean for us information security folk. And this is actually a topic that's quite dear to me. It will become clear very soon why I actually delved into this. And but before I actually start going, I really want to thank BSides and our sponsors, and especially my very now good friend Joel sitting here, which helped me make sure this was appropriate. I guess it's the right word. So just before we start, okay, I have some important warnings here. Number one, this is not about a hack. All right, I'm defending stuff, I'm not attacking. So if you're looking for vanity hacks, you know, I just cracked the root key of Android and that's fixed the next week. This is not a talk for you, okay? So you might as well just go find another place, all right? We're actually trying to build something here, okay? And this is, one of the things I try to go through a lot in this presentation is to try to explain why this could be significant. We, by nature, we are paranoid, we are suspicious of different things, especially if they come with a very big marketing hype on top of them, and this, oh my God, does this have marketing hype? So just want to make sure this is kind of an introduction so we can start getting the conversation going. And there's a lot of math, okay? Not so much as people would start screaming and actually coming here and hitting me, but should be all right? You can just, I'll take any questions about anything later on, so let's get into it. So why do I care? I guess that's an important thing. So I've been doing this for like 12 years, information security. The reason why you've never heard of me is because I'm from Brazil. So most of what I did was there. So I used to actually run a fairly large information security consultancy there. And I got to do a little bit of everything. Although, if you ask me to do it here right now, it would probably suck because it's been a while. But anyway, for 7 years or so, what my day job has really been is about running a SOC, all right? Building the team, setting up those fancy SIM dashboards for customers and things like that. And man, it's very painful. So anyone here who's had experience with that, okay? Yeah. A few hands I see, so you know how this shit does not work, right? And I touch a little bit into that, and I'll touch a little bit about that on another presentation I'm doing, because it's an interesting point at the end. I'm going to skip the mid one, is that this is actually my first presentation at a real InfoSec conference, so thank you very much guys for attending. I feel you're very supportive. Yay. Because 5 p.m. I'm actually presenting a giga version of this in Black Hat. So it's actually about the algorithm that I put together, which I'm going to touch a little bit here. Not going to go into a lot of detail, but anyway. So did all of this shit, got hurt a lot by SIM solutions, and starting this year, I started researching a lot of machine learning and things related to data science, okay, which we're going to touch into as well. And participated in some competitions. I mean, I'm not a master by any chance. I'm probably making some very rookie mistakes in order to put together, but it seems to work fine, so I might as well share. So, okay, here's what we're going to talk about. First of all, we're going to talk about the elephant in the room, big data, all right? We're going to get that out of the way, understand what it is, what it isn't, and then we can start actually talking about machine learning, a little bit about how it works or how it should work for you, and what does it have to do in InfoSec, and a little bit about my project, how you guys can get started if you're interested into it, and some takeaways. Okay, so let's get to it. So what is this big data thing, right? And I think this is a slide that will actually give you a good overview of what people usually understand as big data. So when we're talking about big data, what they should be talking about, I mean, 95% of the time, is Hadoop, right? Which is an open source way for you to put together large amounts of data in this distributed file system. It's called HDFS, and then do a lot of crazy stuff with it, which you probably heard of MapReduce, which would be equivalent to the assembly of big data. So it's actually API in Java, which is pretty funny to call it assembly, but So that's the building blocks or where people build the rest of the stuff. Okay? So when people talk about big data, what they should be addressing in general is some part of this. And you see there's all different things. You can get log collectors from a thing called Flume. This is very much based on Cloudera, which is one of the leading guys. They are like Red Hat was to Linux. They're kind of what Cloudera is what it is to Hadoop, in a sense. So what I wanted to point out here is that there is a machine learning component here. So it's a part of it, okay? It's important to bear in mind you don't have to do big data to do machine learning. What I did here, I didn't touch a single line or a single configuration of Hadoop. I surely will in the future, but not as of now. But anyway, this is like the clean-cut view, all right? This is pretty much what you guys should be wrapping your head around. But then we have this problem, right? Because everybody comes forward and they suddenly they're a big data guy. And they're doing all sorts of different things. So of course you have the base technologies here, okay? But even Oracle will tell you, even though they don't really touch Hadoop, they'll say their original relational databases are actually big data just because you can run it on a 5 machine cluster. Come on, that's laughable, right? When you talk about some of these guys, they're putting like thousands and thousands of machines on Hadoop clusters and running all sorts of crazy shit. And we'll get into this crazy shit, which is actually quite interesting. So there's actually some guys here, we actually do a little bit of that for log applications. So there's no way they're trading this. I'll get a little bit into that as well. But it's very, very interesting. So a funny point, you guys probably heard of NoSQL, right? So we have there's a funny joke. Usually in San Francisco, Silicon Valley, it's like, yeah, no, you know about NoSQL because we currently have like 251 companies who are doing this right now. So that's pretty much, I mean, this is crazy. And all of them will have their marketing message, their hype. Everyone will try to convince you they're doing big data. But at the end of the day, it's more about not how you store it or how you use it. Not how you store it or which kind of capabilities you have around that, but how you actually use it. And this is what I'm trying to do, all right? So let's start with the idea of machine learning. And the point here is that you don't actually, and it sounds kind of funny, especially for some of the developers in the room, you don't actually write the program. You write a program that will be able to learn what it should do from the data that you feed it. So we'll have some examples around that, but it's through repetition, really, okay? So if you are, I mean, you're like a baby, you're just born, and then your parents say, okay, this is a chair, right? And then the first time you see a chair, okay, a chair has to be exactly like that. It has to have this metal frame, has to have this custom stuffing. And but then you see a lot of different chairs, a lot of different models, a lot of different things. Suddenly you can generalize what a chair is. Okay. Every time you see a chair again, okay, that's a chair. I got it. I don't need to. That's moving to tables or something like that. So here's pretty much what we're trying to do. Pretty much what these machine learning projects are trying to do. Then some applications here, right? So I mean, you guys all have seen this, right? You go to Amazon. And it's kind of guesses, right? What you would like to buy or what you'd like to do. And the way it does this, it's actually a method called collaborative filtering, because it figures out, it knows everything you've bought. And it knows everything everyone has bought in Amazon. So they can pretty much measure up who are you similar to. Okay, so you bought all of these hacking books. I've got a lot of people there who actually buy hacking books as well. And you know what? They bought this one that you didn't. So I'm pretty sure you're going to want to buy this one as well. So it's a huge data mining effort. All right, they're crossing. It's like think about a billion degree matrix, right? On every direction. They're just calculating that shit, and they can tell you, okay, you want to buy this book. This has got a lot of press for a few times. It's the high frequency trading stuff. Okay, so actually a lot of the training nowadays is done by algorithms. That's not actually people doing it. And this is actually a picture of when it crashed not long ago. So they got confused and they dropped it like almost 10 points. And then they, wait, let's back up. That's not really the way we should be doing it. I don't know, they found a local minimum in the function and they started selling everything and everybody's, oh my God, he's selling, let's sell everything. So anyway, it got back up, but this is a little bit of the perils, and which I will be talking a little bit about. But anyway, it wouldn't be able to be done without it. You wouldn't be able to do it in that frequency, but sometimes these kind of things happen. And another cool one here, this is actually a project from Google, which they recently put together like, I don't know, 10,000 machines, 16,000 machines, to try to figure out which pictures on the internet were of cats. They really know their audience, right? So they were trying to automate a learning system to identify cat pictures. And it was scarily successful, according to them. It touches on a new field called deep learning, which we should be hearing a lot on the next few years or so. But anyway, this is what they do. What do we do? But what do we should be doing, right? So when you talk about fraud detection systems, they are usually, in a way or another, using some aspects of it. Some of them only do like statistical analysis, but most of them will have something like, they will try to figure out what is your behavior. So this is what you usually do in this region of space, so to speak. So if you do something that's too different from that, they will flag this as an alert. It's called a clustering algorithm. They'll touch this a little bit further as well. There was some people who claimed to do some sort of artificial intelligence on stuff like network anomaly behavior, network anomaly detection. And it's much more like statistical analysis. They were trying to do this clustering thing, but they would always hit on the problem that what is normal in the network. And all of us who had to do sim implementations and had to do some sort of baselining in order to figure out what was the X we had to put in that role, in order to, okay, up to this, it's fine. After this, I'm going to be alerted. That's exactly the same problem that these things hit from time to time. The point I'm trying to make here is not that these things are terrible. They actually help when you're trying to do this sort of sim configuration work, but they're not really machine learning. So you just have to be careful with what you're being sold. All right. The bottom one here is actually one of the things that I'm trying to do, is to predicting the likelihood of someone attacking you. If they come from a specific region of the internet, or they come from a specific, you have some specific information about them, so you can better say, I mean, you're never gonna predict who's attacking you, right? It doesn't work like that. But you can start predicting that if my attack came from this side, okay, I might want to pay more attention because I've seen bad stuff happening from this side than if someone comes to this. It's all a triage exercise. And the more predictive models we can build around this, and it's kind of a trial by error thing, and it's a little bit of what I've been trying to develop. We can increase the confidence in each step. We may get to a point where it actually makes sense to tell a firewall to block someone, because we've seen so much bad behavior in so many different layers of the network that it actually makes sense. We have confidence enough, and that's a word that they use a lot, that this should be blocked. And finally, our good friend span filters. And I mean, if you ever heard of the Bayesian filters, that's it. You're right there. So it's actually the name of a Bayesian algorithm, which I'm actually going to touch a little bit. And anyway, let's carry on that. So, how to do it? There's two very interesting, important points. First of all, you have to mine the data that you have. So, for my example, so I had a bunch of log data, okay, and I was trying to extract features out of it. So, how many times did a specific IP address happens over several days? How many times does a specific /24 net block appears? And then I can start putting figures and numbers to it, and I can actually start counting. It's actually, when people talk about feature engineering, and it's a big word that gets thrown around in machine learning, it's actually about counting stuff, okay? It's a very fancy word for counting, but then you have to try to count things on ways that make sense to the problem that you're trying to solve. So this is actually one of the biggest problems there, and every algorithm development will have this wall, and making sure that the data is good enough for you to use, okay? And bad data can mean data that you can parse properly, or data that, I mean, I've been trying to, for instance, I've been trying to ingest a lot of stuff from SIMS, and most of the time they can't parse it. They can't tell me if this was a firewall block or a firewall out. I mean, simple things like that. And we keep reinventing the wheel, adding new parsers, but anyway. If you ask anyone, they'll tell you that 80% is actually cleaning up the data and making sure that it works. It's usable for you in any shape or form. And about it, when I say exploring the space, is that really, depending on what you're trying to do, there are like dozens of algorithms there which do things in very different ways. And you really have to stress it out and try out different ideas and different things. And you might come up with an algorithm that will actually give you a good result, give you good feedback, and not whatever you're trying to do. Okay? So, delving a little deeper, okay? When we talk about machine learning, we got two different guys. We got what we call supervised learning, which is people that we tell the computer what these things are. So I'll give a chair to the computer and I'll tell you, this is a chair. I'll give a table to the computer and I'll tell you, this is a table. All right? If I give it enough chairs and tables, it will probably be able to tell them apart, which is what the classification problem is. So is this A or B? Or it could be a multi-level classification as well, but let's try to keep it a little bit simple now. Or a regression problem, which is, okay, maybe I got a table with three, sorry, I have like a table with three legs. Thank you very much. You see, that's what native, not being a native speaker does to you. And you have like small benches, right, with only 3 legs as well. And then, okay, that's weird. So this kind of looks like a table, a smallish table, all right? But so, okay, so if from 1 to 0, how much of this is this a table, or how much of it is this a chair? That's what the regression problem is trying to solve. So you're really trying to get a measure from these classes, so to speak, that you have, these labels, where this sits. So they both have a lot of interesting uses. So I'm naming some algorithms here. So neural networks is kind of classification. This is support vector machines. We'll talk a little bit more about that. Naive Bayes, which is our spam filter hero. Linear logistic regression, which you're pretty much fitting a line. I'll talk into that as well. And you got the supervised learning. Supervised learning, you actually don't know anything. So I'm just giving chairs and tables to the computer. I have no idea if it's a chair or a table, and I'm hoping that the computer will be able to tell them apart, all right? So the computer will look at this, okay, these are actually different, okay? So I'm not really sure what this is, I'm not really sure what that is, but I can tell they're different. And then a human can come on, oh, this is a chair, all right, chair. This is a table, and then you can start doing the other kind of stuff. When we talk about fraud detection, okay, it's actually trying to cluster all the behaviors of the users, okay? It will find a lot of users that spend very little tickets, not so often, or spend very high tickets, not so often. So you have all sorts of different classifications. Nobody really knows how many different, and this is what this K stands for, right? It's how many clusters you're creating. These fraud detection things will do. I mean, sometimes it's even a secret sauce for them. Then, if you're classified into one of these groups, if what you start to doing is too far away from where you are, from where you should be, that would be flagged as a fraud. And finally, there's this decomposition solutions, which usually help with the data mining and the exploring the space thing. So if you actually have a bunch of different features, all right, you actually know a lot of stuff about the chairs, about the tables, but you want to try to figure out what are the most relevant features, what would explain better what a table is, what would explain better what a chair is. So, I mean, using the tables and chairs example, would probably height, would be a very good one for chairs and tables. So if it's yay high, it's probably a table, but it's yay, it's probably a chair. But I mean, there's a lot of other different things that have to be considered. So this is when you've got too much stuff on your hands. It's not running properly. You don't have enough time, so you just try to simplify it and then be able to run your model. Anyway, God, this is fast. When we talk about naive Bayes, which is what the spam filters do, it's actually trying to, it kind of guesses, okay, what is the chance that a message is spam? And at the end, this doesn't really matter a lot. The idea is here, if you get a message, how likely is it to be spam, okay? So if you look at those measures, 80% of the messages is spam. Okay, don't care about that, let's make 50-50, all right? So then you start calculating, okay, if I get a word like Viagra on an email, all right, and how likely is an email with the word Viagra is supposed to be spam, okay? And you do that for all bad words like enlargement and things like that, and you start running this for all different words. So what are the chances of an email having this word being spam, and what are the chances of an email having this word not being spam? So when you run this enough times for every single word you have, okay, and they call it naive here because it actually doesn't believe that there's any correlation between the words. So it doesn't think like enlargement should always come after penises, you know? So it just thinks it's completely random. The words appear at random, and if the words are there, okay, that's a spam and that's not a spam. So obviously there's a lot of optimizations to this that people do. They use several words, but that's not the point. And so they just run this model here, which actually calculates the times this word appears as a spam, times what we know as spam appears, and the time that we actually get this word at all. So this is time the word is a spam, times the probability of it being a spam, time the word is not a spam, and times the probability of it not being a spam. So this actually means every time the word appears, right? So then you keep running this, and every time you run this, you're a little bit more confident or less confident that something is a spam. And the reason I wanted to put this into here is because this has been going around for ages now. Okay, I found a paper from Microsoft Research from '98, and we've implemented this. And I don't know about you guys, I don't see a lot of new talks about spam filtering. It's almost like the problem has been solved. All right. Of course, I'm not talking about phishing spam. So phishing spam will be something that will be exactly like what a ham would look like, and that will get through and people will click and all the bad things. I'm not talking about all the crazy stuff you sign up on the internet, okay? That will actually have triggers on the spam filters for not going through to you, to actually go through to you and bypass those spam filters. But it's interesting, right? We got a very high efficacy in this right now. If you look at Gmail, I don't know, I mean, I've had a Gmail account since 2004, right? I don't get spam anymore. I mean, arguably, they are the ones with the largest data set, okay? And also, they have a lot of awesome in-house teams who really understand how this and all the algorithms work. But when you think about that, I think it's a very unappreciated part of information security here, where this concept has been used heavily for ages and ages and ages. Anyway, moving on. Just wanted to throw this out here. I don't want to get too heavy on this, but one of the simplest examples is what's called linear regression. So the idea is, you got some stuff you know, okay? I have the linear combination of some variables. So an example I would give is that, I think that paternities do a lot, all right? So they try to give, they have the ultrasound, and they can pretty much figure out what's the size of the baby, what's its height, okay? So based on the height, and how many weeks of gestation you have, you might want to guess, okay, or infer what would be the weight of the baby once it's born, all right? So actually, they're linear, right? The bigger the baby, the intuition, it makes sense as well, right? Taller the baby, heavier it should be. The longer it is in gestation, yeah, it will get stronger, allegedly. Yeah, anyway, I'm talking about non-disease related stuff. So you can actually get all these observations you have, plot them into different points. So I mentioned something with two variables, so let's think of one variable for now because it's much easier to see. So think about the height. You plot all of this, and then you try to find the line that actually messes up less Okay, so you're trying to find, if you drew a line through this, okay, what is the minimum error I can get on this, which is pretty much the distance between the points you measure and what the line would do. So this is a very classic regression model. Everybody does this for almost everything. This is really an everyday application that is, I mean, it's just everywhere. And if you need to know something to impress your friends, you know, like you're drinking a bar, you want to talk math, this is the one you want to talk about, okay? Because nobody can get this wrong. This is a very cool blog if you're into this, and the guy actually has a lot of visualizations of what these algorithms look like, and it actually, so this would be the probability of where the line should be, okay, based on the error that I mentioned before. And finally, and I promise this is the last one for this. This is my favorite one. I love this shit. Okay, so it's called support vector machines, and it's especially good for classification problems. Okay, so you have a lot of numeric features. Okay, you calculated a lot of likelihoods, a lot of probabilities of things, and then you want to get a yay or nay, or a 0 or 1, or whatever you want to do. So what I really like, so the intuition about that is that, okay, these are two valid ways, and I don't know if the colors is good, but you can tell that this color is different from this color, right? So these are all valid ways of separating this surface, right? These puts all the blue guys here and all the blue, I guess, guys here. But this is a much better one because I have kind of a confidence band there. I haven't seen anyone that could throw me away on this region, so I'm trying to maximize this region error here that you can see, so that, I mean, since I don't know everything, and you always work with limited data, you're trying to make it the most better prediction as possible. The thing that's awesome is that it does a mathematical trick, because you're gonna have a surface like this, right? You can't really throw a line through it. You have got like a very squiggly thing that's going around, and so the math behind this, okay, there is going to be some dimension somewhere where I can just draw a plane or a hyperdimensional plane, whatever suits your math necessities. That this will be linear separable, so I'll be able to try to get a plane equation. And they do the calculations, and okay, this is true. Okay, there is a plane, there is a space where this happens, but we don't really know what it is. It's probably infinite dimensions. Okay, so you do a calculation in an infinite dimension that you don't really know what it is. Okay, nobody knows if it exists or not, but then you can run this and run it back, and you've got it separated here. It's like, this is crazy. This is really, really crazy. It's really exciting. I don't claim to understand it, but the idea that I'm doing calculations on an infinite dimension I don't know at, and the computer is doing it for me, I like that. I like that. You may think I'm crazy, but you're probably right. But anyway, what's the point? Okay, why should we care, right? What is the role of InfoSec here? And anyway, I saw a few hands earlier. Guys, the symlog monitoring stuff we have is actually just vertical data warehousing tools from the 90s. You know, where columnar databases were never invented for some reason. I mean, actually no, they're just coming up with that. I'm sorry. I mean, evil here. So we are really banging our heads against a problem that has been solved again and again by other industries using a very subpar tool. Okay, we don't have the speed, we don't have the agility, we don't have the capability to actually run the queries that we want. Okay, and my point here is that we got a lot of logs. We're getting more and more each day. All the vendors are starting to push big data stuff with their specific tools. And when I say big data, I mean like Hadoop-like storage. Okay, some of them are starting to dabble into analytics, but it's still in its infancy. There's going to be a time where we are not going to be able to deal with all this information. Okay, it's too much for analysts. I believe it's already too much. It's been too much for a while now. okay? And it's only going to get worse and worse, and we need help. We need help from machine learning. We need help from data analysts. We need help from data scientists. And that's pretty much the place where I'm coming from. And so just to make sure that we understand this perfectly, this is what a data scientist should be, okay? So the most important thing, and this guy, this is actually a very cool guy that I met there in the Bay Area, and he has this quote, right? Which is, the guy is better than statistics than software engineer, and better than software engineer than any statistician. And the thing is, you actually got to do a lot of stuff, you know, to be able to do this right. Oh, so just so you're wondering, hacking skills means development in startup speak, right? They totally wrongly appropriated that, but we got to roll with that. They're more numerous than we are, so there's nothing we can do with that. So, I mean, if you have the statistical knowledge, and this is a tough one. This was one I had to really go learn a lot, you know, to not do stupid stuff. And you know what you're doing. You're just a regular scientist, right? If you can program and you know what you're doing, yeah, you're just going to create some killer robots here, you know, machine learning. Let's do it. But I really love the fact that if you know the field you are, you know, and you do have some programming skills, you are totally on the danger zone, because you're going to mess up all the different things, all the statistical significance that you need to have in order to have confidence in a model. So I didn't have time to put it here, but there's a very cool SKCD about that, about people trying stuff on jelly beans. And they tried so many times that they find like an outlier, and they would find anyway. So that's pretty much the problem that we have. But it also could be double rainbows if we get to all of this. And this is also an important consideration, and I think this is the point that, I think this is one of the biggest takeaways to the information security crowd, is that, and it ties into the statistical significance I was talking about. You have to be aware that whatever data you get in, there potentially is some bias, okay? Even if it's a self-selection bias, where you've asked people to volunteer data, okay, this is the kind of data that I get from people who actually volunteer at this. So you might, if you're not trying to generalize or not trying to be cognizant of that, you might make some rookie mistakes. And the thing that I find is most important is actually the adversarial aspect of information security. So once we get more of these models, and once people start developing this, people will find ways to subvert that. So this is something that you also guys have to have in mind. But other than that, if you take those two things into consideration, the more data you have, and this is an error measure. This is the error measure on the data that you have, and this is the error measure on the data that you've never seen before. You know, you tend to have go to what would be the optimum here. You're never going to get to 100%. Okay, that's not what these things are built for. Okay, you can never. Maybe if you saw the whole data set in the world, which you're not, you might get closer to that. But anytime someone tells you that they have like a 100% confidence model, just run away from them very fast, okay? Because they're doing something wrong. So anyway, and then, of course, this is the second point I was trying to give. And I think an important anecdote about this is the way that spam engines evolved. So once people started getting this right, and the Bayesian field started working a little bit well, so spam emails started pasting the words of Shakespeare at the end. Because the number of words there that actually made sense, that could potentially be on an email, they actually would offset the model on the sense of what should be gathered or not from the spam side. So I mean, long time has passed. We all got over that. But this is the kind of thing people will constantly try to test it and try to make sense on how to break this. This is what we do, right? There's a lot of our culture in the hacking community, the real hacking community. It's about actually trying to subvert this. But I think this will get a good run. So anyway, so just to tell you a little bit of what I've been doing. So after all this very, very long introduction of what machine learning is, I've been researching models and ways to create some predictive models that will have information security. I'm sick and tired of looking through logs. You know, I'd rather have a computer look through logs, okay? Tell me what the pain points are, and then I can do some honest to goodness instant response to them, okay? And oh my God, what about the tier 1 jobs? No, they can learn the good stuff, okay? Nobody wants to do tier 1 work, okay? Especially at midnight, okay? They will miss stuff. They will sleep, you know? They will go out for coffee, you know? Just let's try to gain some consistency here, okay? That's pretty much what I'm trying to go for. So if you go to the website, you can talk to me, you can scream at me that I'm completely crazy, or you can sign up, you know, and we can find a way that we can share some logs, and I can use these logs to fuel the model, okay? So just to give you a very quick summary of what I'm talking in Black Hat, what I did was based on some, I mean, I'm not trying to do behavioral analysis here. I'm not trying to count stuff. I'm not trying to infer what's good, what's bad. No. Let's start very low, okay? Let's get everything that's blatantly bad, all right? This guy is scanning your firewall. It can't get much worse than that, you know? So, I mean, all the intelligence community, when they try to make inferences on, I don't know, threats to the nation or something like that, they go from a much less than that. You know, we have actually people trying to break in our doors all the time. We can't tag these guys as malicious, I mean, there's something very wrong here. So let's get what's blatantly bad, okay? And then I went to DShield, okay? The SANS program, it's actually awesome. They take firewall logs all over the world, although I do suspect it's mostly US-centric from the results I got. And they create some summaries for you, top 10 ports, top 10 attackers, and things like that. And if you're very nice, they will give you the bulk data. So I just mined that for 6 months, okay? And what I got, okay, when you do the math, and I won't go through the math here, is that there's a false positive ratio, there's a false negative ratio, so I will get stuff wrong both ways, and that's expected. But at the end of the day, all right, if you look at the result, what I'm telling you to look at should be 13 to 18% more likely to be attacking you than otherwise, okay? I wouldn't go blocking stuff on that still, because it's just, this is the trouble about statistics, right? I mean, what is the likelihood of someone in the internet is out to attack you? If you ask someone from this room, oh, everyone is out to get me. But really, okay? So there's a number there we don't know. It's called prior in many situations. It's one of the things of Bayesian principle. So, but if you are in a position where you are looking through this, you are looking through logs, okay? You are in an analyst position. You've got so much stuff to look at. You can't possibly eyeball all of that, all right? So if you have an aid, okay, that created a separate screen for you, okay, guys, this is like, if you only have time to look 25, look this 25 up, okay? Because they seem to be doing the most noise here. I see some value. I see some value with that. And that could potentially help us move forward and scale, I think that's most important, the amount of stuff we have to monitor. Okay, so blah blah blah, Internet of Things. Yeah, you pay me 6. That's a lot more IP addresses. Screw. Sorry, we have no chance in hell in defending this. We need help. This is what I'm trying to do. So this is one of the visualizations I'm using. So I don't know if you guys ever seen this. This is called the Hilbert curve. This is my attempt to plot the internet. Okay, so what actually it looks like is that if you go it like this, is like the first fourth of the internet, and then it goes here, here, and here. And actually, the way this works, it's like it does something like this. It's it's trying to fill this. But what this construct does is that it's trying to preserve closeness. So it's the best. It's kind of like a map. Okay, when you see a map on the screen, it's not the Earth, right? The Earth is round. You can't just put it on a flat surface. So this is a map that's trying to preserve closeness. So you actually get here the /8s and the /16s or 24s, the closest that we can get to each other. And so this is a very simple statistic. I'm just counting how many times I'm getting blocked port 22 blocked from the firewall. And this is like almost 7 months of data. Guys, this is not random. You can definitely see some hotspots. Oh, by the way, we're here. This is 24/8. The resolution is, I mean, it's not a very big resolution here. It's actually quite a lot of IP addresses. But anyway, we can see some guys we love here, you know. And I made sure to point to 0 here so that people wouldn't think like I was being bad to other countries. But you see, yeah, there's some pretty stuff going here. It's quite more bluish than what's going on around. And this is the kind of behavior that we try to analyze, and then we try to infer some solutions. So this is an idea. This is another visualization on the same vein of what the algorithm is doing now. So what I did here is this is also port 22, right? So just to make sure we keep on the same example. So I got model trained. So this is actually the model from trained on that same day, and I just randomly picked 100,000 IP addresses from each /A, so each class A, okay? And then I asked the algorithm, okay, predict this for me. Do you think these guys would be out to attack me? And then again, always remember, this is from the frame of reference of the guys who are submitting logs to SANS. Okay? This doesn't mean anything, actually means little if you are not part of the data that we're mining. There's actually a transference that you can get, but the more data you have, the transferences should go up. We should get a model that works fairly well for everyone. But the brightest the tile here, you know, more likely are these guys out to get you. So when I say more likely here, I pretty much 100K. Okay, who got flagged as positive? And when I say positive, I mean malicious. So what's the likelihood here of there being a malicious on this sample? So you get from 10 to the -4 to 10 to the -7 here. So the brightest guys here, they're actually almost 100 times more likely for you to see an attack from these guys. Or let me rephrase that. An attack from these guys could, a packet from these guys could be interpreted as malicious, okay, than someone's reason in the darker tiles. So anyway, I actually struggled a lot on how to try to demonstrate this, because this is a very big scale, it's very hard, but I hope I mean, of course, there'll be a lot of, if you guys want some questions. Yeah. So it also does fun things, because I was asking it, I tried, so one of the dry runs I did was in port 80, I had a lot of stuff in port 80, right? So, okay, tell me, robot, who are the bad guys? Microsoft and Google, it knows that shit, right? Actually, no, right? Actually, since what I'm mining is blocks on port 80, okay? It's very easy to see that these guys will always do the Google bots and the Bing bots. They actually don't care if there's a website there. They will just start to connect to port 80, and that's it. But this is the point. One of the points I'm trying to make here is about the data scientist diagram, where we were talking about substantive expertise. All right? If we get this in front of a traditional scientist, they would go, no, this means they're bad. The data doesn't lie or something like that. No. You actually just need to have a different view. You need to create some exceptions. And again, it ties back to the data mining and, in a way, making sure that you understand what the data is telling you, so that you can extract some good results from this. Anyway, sounds cool? How to get started, all right? And I apologize, you do have to program. There are a few like websites that let you do machine learning, but being honestly, they're like so clunky, and you have to know almost as much as you would if you were programming. I personally think they're kind of a waste of time. You're better off trying to learn a language to do that. A lot of you will be familiar with Python. So Python has the pandas library for you creating like data frames and stuff, like you can represent like you would in an Excel table in a way, badly comparing. And the scikit-learn, which I showed in the previous slide, which is actually their machine learning library, which is, I mean, the most popular one. I guess I should be honest about that. And I personally enjoy art a lot. That's where I learned my stuff, okay? And it's a lot slower than would be in Python, but I know it's some kind of personal attachment. I don't really want to talk about it. Anyway, you gotta learn the theory, okay? But nowadays, the internet is an amazing thing, okay? A lot of interesting courses in Coursera, okay? There's also some paid stuff from universities. You will get, traditional education online, traditional college education online for a very hefty price, I'll say, but you can get to interface with these highly, recognized professors in these fields. And of course, you have to practice, okay? It's not just about being a book. So Kaggle is a website where machine learning is pretty much fight to the death to see who comes up with the best model to solve a specific problem. And there's a lot of other competitions. So SKDD here, which is a very famous one. It's not specific about security, but it's about machine learning visualization in general. The VAST challenge, you might have heard of this before. The VAST challenge, every year, they have an InfoSec kind of competition where you're either have to mine something to come up to a conclusion or come up with a visualization that will help you see what's going on. And tangentially, VSAC, okay? So I love data viz. I wish I had. I'll definitely, it's something that I'll be researching more going forward. And they do some very, very cool stuff with trying to visualize the text. And again, it's another way to help the analyst in the way. Anyway, so what do I want you guys to remember? The most important thing is that big data is here, not just kidding. But it is, right? It is going to be a reality. It is going to be something that especially if you're doing defense, especially if you are in a largish, when I say largish, because every single mom and pop shop now will have a log management solution because of PCI. This is such untapped potential there to help themselves on what they could be doing. I really do believe that this will come. Okay? And it should be. I don't think it will come soon enough. I actually, my personal belief is that no big vendor will be talking about this. I mean, we'll be talking about this, but they won't actually implement anything for like, 2 or 3 years or so. And we're going to be left fending for ourselves, everybody's going to like burn out and lose all their hair because they can't make sense of all the data. And then this will start getting to this. I don't want to wait anymore. I'm trying to learn this, and I'm trying to make sure that that's something that we can use as of now, or as soon as possible. Anyway, learn your data stuff, man. This is, as they say, it's the sexiest job in the 21st century, the data scientist, okay? And you think about it, it's actually much better than statistician, right? Only if accountants call themselves like money scientists, man, fuck, rock stars, I mean. And anyway, check it out. It's interesting. Check out my talk if you have the time. So I'm tonight, 5 p.m. at Black Hat now. I'm gonna be in DEF CON on Sunday. If any of you survive the parties on Saturday, okay. And but most importantly, there's one takeaway that I want you guys to have from this talk is that this is what machine learning is all about. All right, and it's a robot you learn, right? Learn by itself. But again, guys, I don't want to add to the hype here. This is not a panacea. You have to know what you're doing, most of all. Okay. So I've been doing this research for less than 6 months. Okay. I still think there's a lot of potential there. I really do. Okay. From the little that I did, and I mean, IP addresses. That's like the lowest bottom feed, in IR, but still, we get some confidence. We might not be the really real hackers or something like that, but think about all the little guys who don't have the money or don't have the expertise or don't have the time, okay, to actually have a very good instant response guy. So, I don't know, I just feel like I've made so much money. I mean, not so much money, but there's so much money being made in consultancy, right? Where people like just sell a SIM and then configure all this shit. And okay, this is not working. Let's buy another one and configure everything. I don't know. I felt like you gotta let's finish this, right? I can't do this anymore. And but anyway, I really want to emphasize that, especially on the danger zone part, you really have to learn this. Okay, you really have to look forward to getting some more technical basis on this, because otherwise this happens. Okay, you don't want that to happen. All right, most important. Anyway, that's it, guys. That's all I have. Any questions? Yes, please.
So, sim versus machine language or something. We spent hundreds of thousands of dollars on sim deployments there, on capital, on consultants to make the thing work, et cetera, there, and have not gotten a lot of value out of most of those deployments. And now we're looking at big data type of scales there. And my concern is that we're kind of reinventing sim, because in order to do the types of data analytics that we want to do, we have to deploy collection agents, Flume and so forth there. We have to do parsing all over again to figure out how to get the elements out there. We're basically reinventing the whole sim stack just to get to the foundational level where you say, okay, now I actually have data that I can feed into my MapReduce jobs, my R machine language algorithms, so forth there. And I'm concerned about the level of investment that we're going to have to do on an individual company basis just to get to a basic level of functionality. Are there solutions to that?
Well, I wish. No, I mean, you touch on a point that I also believe very strongly in. I personally believe that what's going to happen is that in a year from now, these big data products, security products will be released. A lot of people will spend money on them. They will be frustrated as much as they are with SIM, maybe even more in a larger scale of data frustration, And they will just, it will get as much as a bad rap as SIM. Okay, I don't really think it's actual. I don't think SIMs are actionable without some sort of assistant machine. Okay, and the big data stuff certainly is not going to be actionable. What I would suggest, okay, and as painful as might seem for it to come out of my mouth, I would just stick with the big guys for now, in the sense that hopefully they will have a migration path where you have your SIM solution running on traditional relational databases, okay, and then you can. There's a lot of guys in the cloud popping up. Sorry, I'll get it. There's a lot of guys popping up that actually started out as like a Hadoop stack or something like that, mostly in the cloud. So that could be an option. So
on his point, most of especially the bigger SIM companies already have connectors that will talk directly to HDFS.
Yeah, but again, that doesn't mean anything.
But if you can get your correlated data into HDFS that's already been decorated, so you kind of have an idea of what you're going to look for, then that gives you a starting point for your ML.
So it's connectors from, you've already gotten it.
You're already ingesting to your SIM. There's no reason for you to start sending to your SIM and to Flume.
Right.
You can go directly
So
from
go
there
to your SIM and then
into
also send it off
HDFS so that you have a starting point.
My biggest concern, I'm totally with you there. My biggest concern and where I'm coming from is that not a lot of people will have this capability. So, a few of you guys in the room undoubtedly will, and they will get HDFS up and running. They'll start running big scripts on it, all kind of fancy stuff. But are we going back to the old European solutions? All back again? Okay, let's scrap everything else. Let me run some log summarizing scripts here. That's where we're moving back to. Okay? Realistically, if we're not having the same conversation about ingesting more data with automation of this data, we're just going back and everybody's going to be unhappy again. I'm sorry, so you had a question right there.
I was going to ask you about the data quality component of this. When we started looking at this about a year ago, one of the biggest problems with the logs was the quality of it. And have you given any thought to trying to provide input or feedback based on what you've learned? What actually gets put on a log entry run? What do applications have a lot of flexibility with regards to what they throw in a log? And is there a way to increase the data quality to allow for better results?
The way I'm approaching this, okay, and you have to bear in mind that this, of course, this is a work in progress. So So all the data I got from SANS, all the data I got from SANS was already relatively clean. Okay? There, I mean, a lot of missing values. Okay, they had like, it's supposed to be outside files, a lot of 10 dot stuff there, you know. But anyway, you just have to clean this up. But in general, the overall framework I'm trying to create is that if you have an actor, okay, so the log has to have an actor. Someone is doing something, okay? That's the first part, okay? A lot of log entries, you can't really tell who did it. Maybe it was on the log before, or something like that. If you can somehow, first of all, identify a behavior from this log, okay, this is a log that actually tells me something. Someone logged in an application. Someone used this role, specific role he had in an application, in order to, not escalate the privileges. It would be allowed, but he accessed this page because of this. So you start to get actors, you start to get behaviors that you would like to predict or not, okay? And then the hardest part comes, which is, since you have those actors, how can you cluster them in a way that you can start, so for instance, on this IP address example, I used the relative position of them on the internet as a way to cluster it. So that's pretty much the point there. So it actually propagates. So are people from the marketing department more likely to have this or that role? That would make sense. So if someone shows up with that role that's not from this grouping, that could potentially be flagged as a red flag on what you're doing. So that's the way I'm seeing them. Okay, and of course this, like I said, I tried to make sure I got to the ground truth. Okay, so I really couldn't be. I wasn't trying to guess stuff. Oh, is this bad or not? No. Let's go to the most blatantly bad, so that we can start predicting this bad. So maybe if there's something you're looking for, and you can identify that on the logs, you can find the actors, and you can, in a way, cluster them or make sense of what are the relationships between those actors. You could potentially use something.
Yeah, we've just seen that there's certain vendors who I won't name who, as far as the logging, they give you this ones that are just how we're trying to do sorts of cluster analysis and some big notable kind of things and those sorts of algorithms. And it's like if only this vendor would give us this additional information, we would clear that space.
I can only tell you what I'm doing. I'm doing really one step at a time. So I'm very confident this is good for firewall logs, for IPS logs and things like that. These are I have IP addresses, and I can readily find bad stuff. Okay? So then we'll be, I guess, maybe the harder questions. And it's all about the questions, really. Okay? We just have to ask bigger questions and bolder questions, and then start mining the shit out of it. In other words, how much time, sleepless nights, in order to try to find something that fits. Anyone else? Yes, please.
What's your DEFCON Black Hat talk?
The Black Hat talk is at 5 p.m. Today. Yeah, 5 p.m.
What is it?
Yeah, good point. So there's a little bit of introduction. I bash on Sims a lot more at the start. Yes, just one. And I talk just a tiny bit about machine learning, just as much as to get to people don't think I'm totally crazy about the results. How are you doing this? And then it's more than half of the presentation. It's about the specific method on how I mine the logs, how I compose the data, what were the intermediate results, so what do the features look like when they're plotted against each other. So just to try, and it's really trying to tell a story on, guys, this looks like it's working. Please, does anybody else in the room, does anybody think I'm crazy? Does anybody think like I'm doing, no, you're doing like a rookie mistake here. Please, okay, I'll have my life back, right? But I don't know, I really feel like this is something that not only it might be worthwhile as an example of this, but I really want to get this discussion going. I don't think we're doing enough of this. And I really, really think this is the future. We're not going to do it on our own. Not at all. Especially not the boring part. Man, who likes to be sitting through these logs? Let's just give it to the robots, man. Let's just give it to the robots. Anyway, Done?
What about the DEF CON?
It's the same. That's on top. Yeah, it's on Sunday, 1 or 1:30. So if you guys survive, if you wake up like noon, can you get a coffee? Anyway, thanks a lot, guys.
Thanks, Alex, and thanks to our sponsor, Strong Off. I have some swag here to hand